learningspace.com.ng.
Hello out there, you're welcome again to learningspace.com.ng. If in my previous video you understand, we're looking at the first topic in JAMB syllabus, and we are using questions to explain everything. And of course, we have 8 subtopics, so all the questions we are treating explains all those topics. Okay, so now we are still on a fundamental unit. I'd like to introduce to you PCE 1990 question 2, that's PolyJAMB. Okay, which of the following is a fundamental unit? A, Newton. Newton, of course, is the unit of force. Force is a derived quantity, so A is wrong. B is joules. Okay, of course, that's wrong as well. C is watt. That's the unit of power, and power is, of course, a derived quantity. And D is amperes. Ampere is a unit of current, which is current is a fundamental quantity, and amperes is, of course, a fundamental unit. So the correct answer is D. Now, quickly we'll move on to the next section, which is dimension analysis. Now, to correctly solve the dimension of any given quantity, whether it is derived, whether it is a derived quantity or fundamental quantity, this is what you do. You need to know the dimension for length, which is capital letter L, dimension for mass, which is, of course, capital letter M, and dimension for time, which is capital letter T. So we see how we apply all of this in solving question. Now, the first question we have here is PCE 1996 question 2. The dimension of surface tension. R. Of course, to correctly answer that question, you need to know the mathematical expression. Surface tension, of course, is force over length. Okay? Force over length. Now, what do we do to this to get the answer out? Surface tension. So, it's force over length. Now, what is force? Force is mass times acceleration. Now, of course, your mass here, the dimension is capital letter M, is here. Okay, then we need to get the dimension for acceleration. What's the formula for acceleration? It is velocity over what? Time. What's the dimension for time? It is capital letter T. Now, mind the way we are breaking it down step by step. It's very easy. Now, what is the mathematical expression for velocity? Velocity, of course, is displacement. Okay, displacement, you can call it distance. In this regard, it will still oppose. Displacement or distance, if you like, over time. Now, what distance is like length, of course. Now, what is the dimension for length? It is capital letter L. What is the dimension for time? It is capital letter T. So the dimension for velocity is L per T. So now let's trace it up. Let's get that of acceleration. Acceleration here is velocity. What's the dimension? L, which is this. Okay? L per T over time. So that means acceleration will be L per T squared. Okay, so that's the dimension for acceleration. Is that the answer? No. Mind you, we are coming from somewhere, which is the force. Okay? So force finally is mass times what? Acceleration. The dimension for mass is capital letter M. The dimension for acceleration is what we obtained here, okay, which is L per T squared. Now, is that the final answer? No. We are looking for the dimension for, according to the question, surface tension, which is force per length. Now, so surface tension, ST, that's my surface tension, okay, because of space. So your force, it is ml per T squared. That's your force. Over, what's the length? Dimension for length, don't forget, it is what? Capital letter L. So you have this. So the L will cancel L. So surface tension, that's my S for surface, and of course T for tension, equals, what do you have left? M per T squared. So that's your final answer. And that will lead us to option C. That's option C. Now let's take one more on this. We have a UME on this UME 95 question 1. The question is, which of the following is the dimension of pressure? That's P for pressure, which is force over what? Area. Now again, your area is what? Length times breadth, if you like, length times breadth. What's the unit of length? Is meter. Of course, that's of course length, capital letter L. Breadth also is a distance. Okay, that is again capital letter L. So L times L is L squared. So now let us see how we enjoy this together. Pressure again is force over area. Permit me to just carry this dimension for force, the one we derived in our previous question, UME 96 question 2. So what is the mathematical expression? It is force over area for pressure. So pressure is force. What is force? mL per T squared over dimension for area is L squared. So you just put that here. So what do you have? Pressure equals to mL times T squared. It's same thing as having L here times what? L. One of these L, we just cancel this. So you have pressure equals to M per T squared over L. So you have the answer here, M per L per T squared. So that is option M per L per T squared. That's option A. And this is our final answer. Okay.